So this is part one of the Bulk RNA-seq pipeline demo. We will start first with the Bulk RNA-seq alignment pipeline, which is named Bulk RNA-seq. In order to launch this pipeline, you're going to simply launch pipeline within the Bulk RNA-seq widget. And then this will bring you to the sample configuration page. To configure your samples, you're going to click this orange button that says samples configured. And this will bring you to the sample sheet. The sample sheet layout is very simple. You have your sample name, your FASTQ1, which is read pair 1 for your paired end FASTQs. This is where you put the second paired end file, or the R2, and this is where you select your organism. So the first thing that I'm going to do is select my first read pair for my FASTQ and drag it to the FASTQ1, and then I'll select the second read pair and drag it to the FASTQ2. Then I will name my sample. These are yeast FASTQs, so I'm going to simply call this yeast. And then for my organisms, I'm going to select yeast from the drop-down menu. Then I'm going to click done. Now, as you can see, I have one sample configured because I entered paired end FASTQs for a single sample. And then you click next. Because I selected yeast FASTQs and yeast as the organism, I'm going to select yeast pipeline tier or pipeline speed tier, which is intelligently designed to work most efficiently with the yeast reference genome. And as you can see from the speed tiers, you have tiers available for all the reference organisms that you can select from the drop-down menu. Once you've selected yeast, click next, give this run a name. So I'm just going to say yeast bulk RNA-seq, and then I'm going to give it a date, 04/18/2026. And then I'm going to click launch pipeline. As you can see, the pipeline is currently running. And at this point, we're going to wait for the pipeline to run to completion. Excellent. So as you can see, the pipeline has completed running. And one of the really nice things in this page is that you get a MultiQC report, which contains details on not only the quality of your run, but as well as the quality of your alignment. You can visualize this MultiQC report by simply clicking this button over here, or this icon over here, which will open a window where you can easily visualize your QC report. This contains all the metrics that you would require to assess the quality of your run, the quality of your reads, as well as the quality of your alignment. Now, to visualize the outputs that are generated by the pipeline, you simply maneuver to the submission output section of the run history and click explore. And this will take you to the directory where all your outputs are contained. This Bulk RNA-seq pipeline uses star to generate a BAM file from your raw FASTQs. And then the BAM file is used to generate feature counts using the subread feature count package. In addition to that, we also generate feature counts using Salmon, which you might be aware quantitates at the transcript level. So depending upon your workflow, whether you're working with gene isoforms or genes, you can use either the star feature count table or the Salmon feature count table. You also have the MultiQC report within this folder. And then you also have your BAM file with the duplicates marked that you can then use for analyzing RNA variants using, for instance, the RNA-WAR pipeline. So this has been the demo of the Bulk RNA-seq pipeline. I hope you enjoyed this demo. Thank you so much.